I will explain the difference between Arrhenius acid and base and the other theory, the Bronsted-Lowry acid-base theory. According to Arrhenius, an acid is a substance that increases the concentration of hydrogen plus ions, which are known as protons, when dissolved in water. And a base is a substance that increases the concentration of hydroxide ions in water. H plus and hydroxide ion when dissolved in water. So whenever we see an acid that starts with H, according to Arrhenius, this acid, when it's placed in water, it's going to ionize and liberate the H plus ions in it. So H₂O already has its own H plus ions and OH minus hydroxide ions. So when we place acid in it, so the amount of H plus is going to increase. For bases, and specifically Arrhenius base is for the bases containing OH in the formula. So when these bases are dissolved in water, they produce OH minus. So the H₂O, having already H plus and OH minus in it, adding base to it will increase the concentration of OH minus. So if you are asked to write or to define an acid according to Arrhenius, all you need to do is just write the equation, the ionization equation. So for example, if I have HBr or HNO₃, all I need to do is just liberate the H plus ion from it and write the rest. And if I have a base, let's say I have another base, and Arrhenius base specifically works for the bases containing OH in their formula, like LiOH or calcium hydroxide, CaOH2. So when this LiOH ionizes, it gives me Li plus and OH minus, whereas when calcium hydroxide ionizes water, I get 1 Ca and 2 OH minus. However, this definition doesn't account for bases that do not contain hydroxide ions. Like, how can I explain that an H₃ is a base? In this case, we have another theory, which is Bronsted-Lowry acid and bases. This theory provides a broader definition of acids and bases compared to the previous theory. And it classifies acid as proton donor and bases as a proton acceptor. So if you look in this diagram over here, that's the base and that's the acid. Why? Because H₂O is now OH minus, 1 H plus less, and an H₃ has now an H₄. It's 1 more H plus more. So if I look at it in a diagram like that, I see that this is the acid having a proton over here, the acidic H, donated it to the base. So this is a proton donor, which makes HA an acid and makes B a base. Now, always in Bronsted-Lowry acid-base theory, we deal with something called conjugates. Acid becoming a conjugate base. This pair of substance, of particles, they come together. What is a base becomes a conjugate acid. So the pair here is HA turning to A minus. That's the acid. That's the conjugate base of that acid associated together. And that's the base that turned into a conjugate acid. So the base turns into a conjugate acid, and vice versa. An acid turns into a conjugate base. So you see here, B was without H, and now it's H and the plus. So a proton donor is an acid, a proton acceptor is a base. Here's another diagram. This is the hydrogen plus ion, and it was donated to this one. How do I know? I just look at it here. There were 2 H's in this water molecule, and now there are 3. So this is becoming, so this is the base accepted a proton from the acid, and the base turned into a conjugate acid, and the acid now doesn't have this H plus here anymore. It turned into a conjugate base. With this theory, we were able to identify more range of bases, the bases that do not contain OH in their formula.